Question 9. Water is sent from a fire hose at 24 meters per second at an angle 40 degrees above the horizontal. What is the maximum height reached by water? So water is sent at an angle 40 degrees, 24 meters per second. What is the maximum height reached by the water? So the maximum height reached by the water, this water is sprayed out at 24 meters per second, an angle 40 degrees. So we know this comes from projectile motion and energy, well, mostly from projectile motion. We know that there's an x component and a y component to velocity at all points. And we also know that the only thing that's changing is the y component. The x component is constant throughout. It stays the same throughout your projectile motion or your constant acceleration motion. There's always constant velocity in the x direction. But the velocity in the y direction is constantly decreasing because of gravity. Gravity is reducing this to when Vy becomes 0 right at the highest point. So that's the condition we're going to use. We're going to use the condition that the y component of velocity becomes 0. And so what is the, using that, what else can we use? We know initially this only has kinetic energy. So kinetic plus potential initial will be equal to kinetic plus potential final. Initially it only has kinetic energy, but we only care about the y direction because the x direction is just going to cancel out. The x here, the x kinetic energy due to x component of velocity here will be the same kinetic energy due to x component because the velocities are the same. So I only care about the y, so half mass times velocity y squared plus potential energy. This is at 0 height, so potential energy is 0 initially. Kinetic energy final y component of velocity final is 0, so this is going to be 0 plus potential energy final is going to be density times g times height. And what is height? Height is what we're looking for, right? It's the maximum height. So now this is going to be half mass. Now this isn't 24 meter per second. This is the y component of initial velocity. So it's going to be 24 sine 40 degrees squared equals density, which is 1,000 kilograms per meter cubed times 9.8 meters squared times height. And now we can find h. Oh, what's mass? It's not mass here. I used the wrong equation. It's density, right? Because we're talking about a liquid now. So wherever you're used to seeing masses, now you'll have density. So you can actually cancel these two guys out, right? And then you could find h without much issue.